Okay, I want to go over some of the trig identities that we did in class on the worksheet 5152 review worksheet that is on Edmodo. So let's just take a look at a few of these, and again, the thought process is we're actually trying to prove that these things are equal to each other. So this equal sign here is kind of in question. We can't treat it like it's an equation and like add something to both sides or multiply both sides by something. We have to really work with one side at a time. Now we are allowed to do some things to both sides individually. Like I could replace that secant with 1 over cosine and then try and get the left side to just be cosine or 1 over cosine. So you don't have to stick to just one side, but you can't do the same thing to both sides or add something to both sides. So it's kind of one side at a time. So what I like to think of is think of it like a big wall dividing these things, and you can work usually with the messier side first, so the left side over there. So let's just start rewriting a little bit. So cosine x, sine x. What I'm doing first is trying to get everything in terms of sines and cosines. So I'm going to replace that tangent with sine x over cosine x. And then just throw some ones under these just to get everything with a fraction. And then basically what we end up noticing is we actually have cosine x over 1. These two terms here after the plus sign can be multiplied together. Okay, we don't need a common denominator to multiply fractions. Okay, so we have sine squared up top there. And now that we have two fractions that we're trying to add together, now I do need a common denominator. So I'm going to use the denominator of cosine x. So the term on the left is the one that needs to get multiplied. And if you're ever multiplying just one term by something, you better multiply it by 1 so you don't change the value. So in green there, cosine over cosine is really just another way of writing 1. And what it allows us to turn this into now is cosine squared. Okay, I'm doing just this term right here. It's cosine squared x over cosine x. Okay, the term next to it, we didn't need to do anything because it already had the denominator that we wanted. Okay, and what this allows us to do now is write this as one big fraction, because they do have a common denominator now. So I'm just going to simply write this as cosine squared x plus sine squared x. And that's all over cosine x. Okay, I just took the two fractions and combined them into one common denominator. And then what I'm noticing now, I'm still looking on the left side of the equation here, so that numerator is really just 1, isn't it? Sine squared plus cosine squared is your basic Pythagorean identity. So it's 1 over cosine x, and that, of course, is secant x. Okay? So that's what the other side of the equation wants to start with, so we are kind of done here, and everything works nicely. Okay, the next problem on the worksheet, secant x minus cosine x equals tangent times sine. And this one, it's not really clear which side you want to work with first. I generally like to think of the side with the subtraction is going to be a little bit messier because we're going to probably need common denominators and whatnot. So I would suggest starting over there. So let's get everything in terms of sines and cosines first. So secant, again, recognizes the reciprocal of cosine. I'm going to throw a 1 under that cosine. And then I'm going to do the same thing we did in the other one. Okay, I want a common denominator since we're subtracting fractions. So this one could get multiplied numerator and denominator by cosine x. Okay, and what that's going to give us is still 1 over cosine x here. Okay, but this other term now, okay, so all I'm doing is multiplying these two fractions together. The numerator is cosine times cosine, so cosine squared. The denominator is cosine x. Okay, and now we got our common denominator, so we can write it as one combined fraction. The numerator is 1 minus cosine squared. The denominator is cosine of x. Okay, now that 1 minus cosine squared looks like one of our Pythagorean identities. So off on the side here, I'm just going to kind of jot down the main one. Remember, the main one's sine squared x plus cosine squared x equals 1. So in our problem, I'm looking for how can we get the variation of that to be 1 minus cosine squared x. Okay, so you can just kind of do the one little step here if you need to make sure we don't make any mistakes in here. Just do the algebra on it, just manipulate it. This way you don't have to memorize all the variations, just know the main one and kind of be able to go from there. So this is kind of just a little bit of side work, scratch work. It's not really part of this problem specifically, so I would do it off on the side somewhere. But it gives you an identity to use. So that highlighted numerator there is really just sine squared written in a different way. Okay, and now if you want to, you could keep going on this, or you might want to look at the other side of the equation. So I'm looking up in the numerator of the, I'm sorry, in the other side of the original problem. It's tangent secant, and looking back to where we just finished up over here, I can kind of, I'm sorry, it's tangent sine x on the highlighted part. We have sine squared over cosine, so algebraically, if I'm looking, I know it needs to be tangent times sine. So from what we have here, sine squared, I could actually write it like this. So that's just doing algebra. That's just splitting up, basically. All I did was split up the sine squared into sine times sine. Okay, and you can think of there being a 1 under there if you want. Okay, and the numerator is just cosine, and the other, I'm sorry, denominator is cosine, the other denominator can just be 1. And then we should be able to recognize now your sine over your cosine, that's tangent x. And sine x over 1, of course, is just sine x, and that was what we were trying to show that it equals. Okay? So kind of peek over at the other side from time to time, and it kind of tells you almost what to do next. Okay, so that's why these problems are not quite as bad even as the ones in the first section, because we actually know what we need to end up with. Okay, so that's the second one. Number 3 here, this one I think should be the quickest one. There's no adding or subtracting going on, so we can really just turn everything into sines and cosines. So tangent sine over cosine. And since we don't have anything to add or subtract, we're not going to need to worry about common denominators. So just recognize cosecant is 1 over sine. Cosine, of course, is just cosine over 1. Okay, there's my equal sign there. So I'm going to draw the wall so we don't cross the wall. And then it's just a matter of simplifying, reducing now. Since it's all straight multiplication, common factors in the numerator and denominator can cancel each other out. Okay, so this thing's real quick. It's a crazy looking one there. Let's just make it fancy. I'll keep my ones the way I like them, straight line. Okay. All right, this one a little messier. So again, let me I know I'm going to work on the left side. Seems like most of these problems I work on the left side, but that's because it's the way they're written. That's been the messier side, and this time it definitely is. So we have those denominators there. So what I would think about is getting a common denominator. Okay, so the common denominator is actually going to be both of those terms, and they're nice conjugates of each other. So hopefully that jumps out at you too, because a lot of times when we use conjugates, things simplify nicely. Okay, so let's see what I mean. Let's do this first one on the left here. I want its denominator to be sine t plus 1 and sine t minus 1. So the good news with conjugates is if you FOIL those out, and I'll just kind of walk through the first one here. Here's sine squared t. Okay, what's going to end up happening in the middle when you do sine of t times minus 1, so that's a minus sine t. Here's a plus sine t. Okay, with conjugates, those will always cancel each other out. So you'll just need to do the final term of the FOIL or the distributed, which is just going to be the minus 1. Okay, so sine squared t minus 1. And a lot of times, conjugates multiplied together will give you one of your Pythagorean identities or a variation of it. So, okay, so let's keep that. The numerator, I basically times all that stuff by 1, so it's just going to stay the way that it was. Sine t plus 1. Okay, now the term on the right, let's get this a little more space here. It needs to get multiplied by its conjugate from its denominator. So sine of t minus 1, top and bottom. Okay, so we got the plus sign in the middle here. The numerator is just 1 times all that stuff, so it's just itself. And its denominator is the same as the other denominator, distributed out. It's sine squared t minus 1. Again, I haven't messed with the right side. I'm not going to, at least yet. All right, so now we have common denominators. Okay, that was our entire goal here. It was a big part of our first step. get the denominators the same. So some of you guys might want to replace that with the Pythagorean identity. I'm going to do that in the next step here, just to clear up the fraction use. So basically in the numerator now, the numerator is just all of this, and it's just being added together. It's just combining like terms. Okay, so it's sine of t plus 1 plus sine of t minus 1. It's addition here. Okay, so the sine of t plus the other sine of t is 2 sine of t. Okay, and then we have a plus 1 and a minus 1. So since it's just addition, those would just add up to be a 0 or nothing. Okay, now the denominator. Okay, and again, this is just one option. Again, going back to the almost scratch work here, sine squared of anything plus cosine squared of anything equals 1 from our basic Pythagoreans. In our problem, we're looking for an equivalent to sine squared t minus 1. Okay, and it's not cosine squared. Okay, so notice, if I want sine squared t minus 1, okay, I can't just subtract the sine squared to the other side, because that would be 1 minus sine squared. We want sine squared minus 1, so it actually just kind of makes everything the opposite. So if we do the algebra on it, what I could do is subtract 1 first, just to kind of show the full steps here. And then to get the thing we're looking for, the highlighted piece, we have to subtract cosine squared t. So the equivalent is actually negative cosine t. Negative cosine squared t, I should say. Okay, so just be careful on that. It's real quick to jump to cosine squared when you see that, but it's not. This is really 2 sine t up top. The bottom is a negative cosine squared t. Okay. And let's see how we're doing. Let's look back up at the other side here. The thing we're trying to prove that it's equal to is negative 2 tangent secant t. So now might be a good time to work with that side if you want to. So let me just write that down here. Negative 2 tangent t secant t. Can we prove that that's the same as what we have on the left there? Okay, so negative 2 tangent is sine over cosine. And secant is 1 over cosine. Okay, and I think we're showing these are the same here. Right, or they're going to be, right? Because if we multiply out one more step over here, the numerator is negative 2 sine t. The denominator is cosine times cosine, so cosine squared t. Okay, and the negative looks like it's in a different place, but remember, in a fraction, if one of the pieces is negative, then the entire fraction is negative. So we could write, we could do it this way if we wanted, just to show they're exactly the same. Okay, there we go. Okay, this one, again, both sides kind of look similar. One has a subtraction sign in the middle, so let's start with that side. Let's go sines and cosines. So sine squared x over cosine squared x. Okay, this one, sine squared x over 1. Okay, so we'll do similar to the first couple problems where we need a common denominator. Let's make it cosine squared. So this term over here needs to get multiplied top and bottom by cosine squared. Okay, so we'd have sine squared x over cosine squared x minus sine squared cosine squared. Should be writing those x's in there. All over cosine squared x. Okay, so that was just multiplying these two together. So there's nothing else we can do. We just got to write them next to each other. Okay, but this now at least allows us to write it as one big combined fraction. Sine squared x minus sine squared x cosine squared x. And they both have the same denominator. Okay, so I saw a lot of people getting here and kind of getting stuck. A lot of times you want to try and just do some algebra. So what I mean by that is, looking at this piece here, I'm seeing that both of these terms have a sine squared x in there. So kind of like factoring the numerator, they do have a common term. So bring the sine squared x out front. So then sine squared x times 1 would get me sine squared x, and sine squared x times cosine squared x would get me back to the sine squared cosine squared x. Okay, so let me just hit that step again because I saw a lot of issues. So again, common factor, right? Just looking at the numerator, common factor gets brought out front. Okay, the leftover factors are in the green parentheses there. Okay, and some of you guys are seeing why that helps us. Look at in the parentheses there, that's one of our identities, the Pythagorean identities. Okay, so this is sine squared x, that's the one that's highlighted out front. This right here is another sine squared x from the Pythagorean identity. The denominator is cosine squared x. Okay, so now keep it in mind what we want to show it equals. Tan squared times sine squared. So this is the other side here, just rewriting it. I haven't really messed with it yet, so we still got the wall up. You know, a couple things you can do. You can change this side now. Looking at what we have over here, I know tangent squared is sine squared over cosine squared times that sine squared, and you can kind of see that those really are just equal to each other now. Okay, so that's fine as long as whenever you get both sides the same, you're golden. Okay, and then the last one on here was an actual equation. Let me just rewrite this again. Tan of x equals root 3 over 2 times secant of x. Okay, so directions are different here. We're actually solving for x. We're not proving it's an identity. This actually is not an identity. Okay, there are some x values where it works. There are some angles that work, but it doesn't work for all. Okay, so the directions are not to prove it's an identity. Just solve for x. So there's a couple options here. What I would try and do is actually try and get all the variables kind of on the same side. So basically what you can do, you can change that to sines and cosines right now if you want. I'm actually going to do that in a second. I'm going to divide both sides first though by secant of x, just to get the variables on one side. So we have tangent of x over secant x equals root 3 over 2. Okay, now might be a good time to go sines and cosines. So tangent of x is sine of x over cosine x. Secant of x is 1 over cosine x. All right, and we know that all of that equals the square root of 3 over 2. Okay, so notice, in the first step, I was able to divide both sides by something because this is solving an equation, not proving an identity. Okay, I just want to make that point one more time. All right, now let's simplify a little more. Sine of x over cosine of x divided by 1 over cosine. Okay, we're going to multiply by the reciprocal. So I'll keep sine of x over cosine x times by the reciprocal of this guy. Okay, and we can see again, since it's all multiplication, we are able to cancel factors now. Cosine x over cosine x is 1. So this is sine of x, and the other side of the equation was root 3 over 2. So we have to figure out what x values have a sine of root 3 over 2. Okay, so you have a few options. You can either go calculator and do an inverse sine on both sides. And if you're in degree mode, that's usually a way to help you get one of the answers. If you think unit circle, sine is positive in the first and second quadrant. So there's going to be some angle up here, and then that reference angle will be similarly placed in the second quadrant to give us another answer. But however you do that, if you need to use your calculator, go ahead and do the inverse sine of root 3 over 2. You're going to get 60 degrees for the main, kind of like the more obvious answer. Okay, or if we want radians, pi over 3, 180 over 3 is 60. Okay, now to get the other one, we need to know that that reference angle down here was 60. So the actual other answer in the second quadrant, all the way around, is 180 minus that, or 120 degrees. And then in radians, if you did the calculations, twice as big, right? 2 pi over 3. Okay, so that'd be your answers. If if they said give all real answers, you might need to select on the plus 360K just to get all revolutions around the circle, depending on how the directions are stated. Where K can be any integer, you can go around the circle many times as you want, or negative times if you want, or just once, or no times at all. And you just be with the 60 and the 120. All right.